I don't know, but it works.
Okay, guys. We are picking up from yesterday where we left off with radicals and roots. Now, as a brief review, remember when we were going through these in the middle section here? If it was something like a square root or a fourth root, what kind of answer did we have to give? It was a plus or minus, right? As long as it was an even root, fourth root, square root, we had to give plus or minus. Unless, what was the catch? We can't take the square root or fourth root of a, no? Negative, right? Okay? And because in that case it's imaginary, but we're not talking about imaginaries, it just wants our real one, so no real roots. If it was an odd root, like third roots, fifth roots, seventh roots, how many answers did you have then? Cube root, fifth roots, we always just had one answer. And what about the sign on that answer? The sign matched the original problem. If it was a negative, my answer was negative. If it was a positive, my answer was positive. Okay, so that's kind of what we talked about yesterday. They were always asking, what are the real roots? And so we are giving the answers. Now, there is a slight difference on this bottom section, but for the most part, it's the same. So A asks us for the cube root of negative 8. Thoughts on the cube root of negative 8? Okay, thoughts on the cube root of 8? Start doing some guessing and checking, guys. 2 times 2 is 4, times 2 is 8. How many 2s did it take me to get 8? 3. Okay? And I was just doing a guess and check. Your calculator can do these too, but it's going to be helpful if you just know some of the basics. And the more we work with them, I'm hoping you will. Now, because it said the cube root of negative 8, what's that mean? What's my answer going to be? It's an odd root. It's a cube root. Can we do a negative? Yeah. Think about it. Negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Okay? Know that an odd number of negatives gives you that negative. So what's the cube root of negative 8? Negative 2. Okay. So nothing different there. B. What about the square root of 400? Again, I would challenge you before you just automatically grab the calculator to think, what's the square root of 4? Square root of 4 is 2. So we know there's a 2 in our answer somehow. Now, this is 0.04. You remember how we talked about this? Square root of 0.04 is 0.2. Here's my proof to you guys. And I know some of you guys are going to say, I have not multiplied decimals by hand in so many years, I don't know how. That's the unfortunate part. Okay, if we're multiplying this by hand, guys, 2 times 2 is 4. How do we decide where the decimal goes? Well, you count how many numbers are after decimals. There's 2. So what do we do here? 1, 2. There has to be 2 numbers after decimals. What's the common wrong answer you guys were giving? 0.02? Well, think what happens here. 2 times 2 is 4, but how many numbers do I need after decimals? 4. 1, 2, 3, 4. And we just doubled the number of decimal places. Okay, so my point is, if there's 2 decimal places, and you're trying to take the square root, divide it by 2. So, square root of 0.04 is 0.2. It's a square root. What would you guys have told me yesterday? When we did square roots up here, what did you guys put in front of your answers yesterday?
Plus or minus.
Plus or minus. Now, that was yesterday, and that was when they were asking me for just the real roots. Did they ever use the radical signs as they were asking questions here? I used them when showing my work some, but did they ever put them under a radical? Okay, so here's the catch, and Math Excel will get you on this if you're not careful. They do not want a plus or minus right here. When they put the radical, and they ask you for the square root and they're using the radical, they just want that positive solution. If they wanted the negative solution, they'd put a negative in front of the radical and you just give the negative solution. But because it's the radical always indicates just the positive solution. And that's when we're talking about even roots, like square roots, fourth roots. So I'm going to write a note here. So you have it to see. And I'm going to say radical, the radical sign represents only the positive root in an even root. Okay, so I suggest you write something down like that, or as long as you can remember, because Math Excel will get you. They'll sometimes want the plus or minus if they just ask what are the real roots of. If they have it under the radical, they just want that positive there. So just kind of beware. Okay, when you're ready. Still see a few people writing here. What about the fourth root of -1? What was it? Okay, so this is no real roots because it's an even root, right? We can't take an even root of a negative. We were okay over here on A because it was a cube root, right? Odd roots, you can just carry the sign down. Even roots, can't do it. And your calculator backed you up on that, right? No real roots.
So any even root, you can't do that.
Yeah, anytime like a square root, a fourth root, a sixth root, an eighth root, if you have a negative under the radical, it's a no-go. Okay? Unless we're talking imaginary numbers, but we're not this chapter, so. Okay. Thoughts on D? The square root of -2 squared.
That's what I thought. It's -2 times -2 is 4 the square root of the first 2.
Okay. -2 squared, if you go ahead and do that math, is 4. And turn it around, the square root of 4 is 2. Okay. A common mistake there would be to say -2, because we often talk about how a square root and a square cancel each other out. But the thing is, that's a radical. The radical just wants the positive solution. And so that's why I'm getting the +2. Okay, get what you need there. Turn to the next page. What's different about this backside?
Huh.
No one's going to give me the real answer. I only get all the smart aleck answers.
Oh, there's A's and B's.
There we go. Okay. There's A's, B's, there's variables. Got it. Okay. Took us a little while, but we got there. Okay, so on the back side, we are dealing with variables. The basic idea of how to deal with variables is going to be pretty easy. The catch is there are going to be times when we have to consider absolute value. And here's the deal. On that problem we just did on the front side, when we took that square root, because it was a radical sign, we had to make sure that we gave a positive answer. And that's the key we're going to have to run into here, is that we have to make sure we give positive answers when we have an even radical. So the rule right here, for any real number a, the nth root of a to the n, referring to this n right here, the index, so like what root it is, my answer is just going to be a if n is odd. So in other words, if it's an odd index, like a third root, a fifth root, we don't have to do anything special. However, if it's an even root, so a square root, a fourth root, a sixth root, we're going to have to consider absolute value. We won't always have to put it on there, but we're going to have to consider absolute value. Because if we have x in our answer, do we know what x is? No. Maybe x is 5. Then it's positive and just fine. Maybe x is negative 7. Well, if it came out of a radical and it can't be negative, we need to use absolute value. So I'll explain that as we go. But I just wanted to mention that piece up there. There are problems in Math Excel that require absolute value. I know several of them I looked at, they gave in the directions, like hint, remember to consider absolute value. Although I know there's at least one I had to use absolute value and they didn't tell me in the directions that. So we have to consider these rules. Okay, so let's look at A. Square root of 16x to the 8th. Any thoughts on what the square root of 16x to the 8th might be? Okay, how about the square root of 16? Square root of 16 is 4. Yes, because 4 times 4 is 16. Now, for the next part. Okay, 4 times 4 was 16, right? A number times itself. I need something times itself, which gives me x to the 8th. So x to what power times itself gives me x to the 8th. Yeah, because what do our exponent rules say from yesterday? If you have like faces and you're multiplying, then what do we do with the exponents? We add. So x to the 4th times x to the 4th is x to the 8th. So what is, I'm going to give you an even shorter and easier way. So what is the square root of x to the 8th? X to the 4th. Now, the easier way is to take this 8 right here. It's a square root, right? So what's the invisible number that's right here for a square root? A 2. The easier way is to take it and do 8 divided by 2. That will always work. Okay? For exponents, it's different. You're not trying to actually take the square root of 8, but take that exponent and divide it by whatever root you have here. So in this case, it's 8 divided by 2, and 8 divided by 2 is what we already came up with of 4x to the 4th. Good timing. Okay, now, before I move on, all 6 of these problems, I'm going to ask you about absolute value. So the question is, do we need to consider absolute value? And here's the, okay, so first of all, how do I know if I need to consider absolute value? If n is even, we need to consider absolute value. What was my n value here? N was, what root was this? This was a square root, so what do you know about 2? 2 is even. If 2 is even, that doesn't sound right. If that root is even, then we need to consider absolute value, which means what you're going to see me do is I'm going to throw absolute value on the whole problem right now while we talk about it. And then I'm going to decide. That's not my final answer, because I have to look at each part and decide, do I need to keep the absolute value on it? So look at 4. Do I need to keep absolute value on 4? Could 4 be negative? No, 4 is just 4, right? Did I ever have negative 4 written down? No, 4 is just 4. So do I need absolute value bars on 4 to tell me it's positive? No, it was already positive. So you're not ever going to need absolute values on the actual numbers. Now, x to the fourth. Could x to the fourth be negative?
Yes. Yes, it can. Because we don't know what x is, right?
Okay, so we don't know what x is. Okay, think with me. If x is positive, what happens when you multiply a positive 4 times?
Oh, it's still positive.
That's still positive, right? So we don't, but let's play the what if game with a negative. What if x is negative? What happens when you multiply a negative times a negative times a negative times a negative? What happens when you multiply an even number of negatives? It's always positive. So could x to the fourth ever be negative?
No.
No.
Because it's a positive.
Because an even exponent will always yield a positive.
So say if it was x to the third, would you have to put the brackets around like another bracket instead of bars around the x to the fourth?
Yep. Okay, so in this particular problem, I do not need any absolute value bars in my final answer because 4, it's already positive. It's good to go. X to the fourth, it's an even power. It's always going to be positive. What if it had been x to the third? Then we'd still have to have the absolute value.
And you just put it on the x.
Yep. I know what you meant. Okay. And this was all because it was an even root we were talking about, right? Because it was a square root. Okay. Let's look at B. The cube root of a to the 6th, b to the 9th. Okay. Hold that thought for a moment. Let's just find the cube root of a to the 6th, b to the 9th first.
Oh, a to the second, b to the third. I think.
He says a to the 2nd, b to the 3rd, he thinks.
And I took 6 divided by 3, that's 2, 9 divided by 3,
You guys with him?
So,
What are we doing? It's a cube root, so we're taking each of the exponents and dividing by 3. So we're doing 6 divided by 3 and 9 divided by 3. So a squared, b to the 3rd.
And you have to have the absolute value bracket down to the 30.
Okay, so hold this back up for a moment. My question again on every problem when there's variables are going to be, do I need to consider absolute value? To even consider absolute value, go back to the original problem. What kind of root was this?
Or negative.
It was a cube root, which is odd. Can cube roots have negative numbers? Yeah, remember earlier we did the cube root of negative 8, and the cube root of negative 8 was negative 2. Odd roots, the absolute value doesn't apply. Because it is an odd root, we don't even consider absolute value. That only applies on the even roots. So my answer is a squared b to the 3rd. Only focus on the absolute value when it's a square root, 4th root, 6th root.
why do we not have to put it in the box though? The lines.
Because 3 right here, the root is odd. And we're allowed to have, like if you flip back to the previous page, we did the cube root of negative 8, and that is equal to negative 2. You're allowed to have a negative answer in an odd root. Okay, just not in an even root. Whereas if I say, what's the square root of, I'm trying to think what was on the other page, I don't remember. Can we do the square root of a negative? We can't do that because of the negative. And so that's what we have to watch out for. Okay? Okay, let's try C. And good news, regardless, if you ignore the absolute value, these problems are actually pretty easy.
I don't get why that's even.
Okay, 4th root of x to the 8th, y to the 12th. How do I do the 4th root of x to the 8th, y to the 12th? You guys okay with this? This power, or not power, the root, the 4th root says I divide it. So it's 8 divided by 4, 12 divided by 4. So that comes out to be x to the 2nd, y to the third.
It's almost like B.
Do I need to consider absolute value?
Just because it's an even number.
Okay. It was a fourth root,
Yeah, that's even.
and hopefully we all recognize 4 is even. So that means I need to consider absolute value. So for notes purposes, I'm putting the absolute value on there to make you think about it. Whether we end up with any in the final answer or not, I don't know. Okay, so the absolute value bars are, if anything could possibly end up negative, it will prevent it from ending up negative.
Would you have to put an absolute value bars around the line with
Okay, well, what I'm doing, so technically what's going to happen here is we're not going to have absolute value bars around everything in the final answer. What I'm doing right now is just to get us to think about it. Okay, so we take this fourth root. Could an answer of x squared ever be a negative?
No.
No, because anything raised to an even power is a positive, right? So x squared, no matter what my answer looks like, will not have absolute value bars on it. Now, y to the third, could that be negative?
Yes.
For example, what if y is negative 2?
Exactly.
Then y to the third is negative 8. Are we allowed to have a negative answer coming out of an even root? No. So that means I'm going to leave absolute value on my y to the third.
Why couldn't you just reference the whole thing? That wouldn't do anything to that, just a second.
I agree. However, Math Excel won't agree.
On a test, would that be acceptable, or would you rather just have it with just the one?
I'd still kind of rather you have it on just the one.
Right? I mean, I get that, but it's just a question.
Okay. Do we see where we're going with that?
Yeah, I'm done with almost.
Of course you are. Okay, let's try D for the rest of us. Square root of 81x to the fourth. Square root of 81. 9. Square root of x to the fourth. X to the second, and why is that? Yeah. Take that 4, divide by 2. So this is 9x squared. Same question I've asked the last 3 problems. Do I need to consider absolute value?
No, because it's even, because there's imaginary 2 outside of that.
That means you do need to consider them.
Oh, I had it backwards.
But you don't need them because it's positive. Not positive and even exponent.
Okay. So it was an even root. So yes, we're talking about absolute value at least.
But you don't.
Do I need absolute value on a number 9?
No.
No, absolute value makes something positive. 9's already positive. Definitely don't need absolute value on 9.
Say there was like a negative number in there because you put an absolute value on it. Like say it was a negative 81.
If there's a negative 81, we wouldn't be doing this square root. Because you can't take the square root of a negative number. Okay. Do I need absolute value on x squared? Could x squared be negative? No, because what happens when I multiply? Okay. Say x is negative 5. So x squared is going to be negative 5 times negative 5. What's a negative times a negative? Positive. So you cannot, when you multiply negative times a negative, it's always going to be positive. So this does not need absolute value. It is just 9x squared. What about E? Guys, is Xavier going too fast?
No,
So Mr. Sargent's probably going too slow is what it is, but that's all right. Okay, so what are we doing with the 12 and 15? Dividing them by 3. So A to the 4th, B to the 5th. What about absolute value?
No, you don't. It's
What are you doing?
So I have them mixed up.
Oh, this was so easy.
Hey, I've got the concept down.
Okay. Okay, we're getting there. We're getting there. Okay, so because it's an odd root, guys, odds. I get a cube root of a negative equals a negative. I want to allow negatives on odd roots. That's why I'm not putting absolute values, because I want to allow negatives. So this just stays a to the fourth, b to the fifth. Okay, F. The beginning part is easy at this point, I hope. If you've been awake and with me, the beginning part is easy. X to the 12th, y to the 16th. What are we doing with those? Dividing by 4.
See, I got that one. It's just on the last one. No, I did.
Okay, so I'm still taking it at a snail's pace. Sorry about your luck. Some of you got it. Excellent. For the rest of you, if there's any questions, and are we considering absolute value? Yes, because that little 4 is even. Could x to the third ever be negative?
For sure.
Yeah. If you have a negative number, 3 of them are a negative. So we need absolute value there. Y to the 4th.
No.
Could that be negative?
No, because it's exponent.
No, because if you multiply 4 of something, an even amount of something, it will always be positive. We did 6 of them. Hopefully they're starting to get there. Some of you are definitely there. I'm seeing lots of connections. So because there's words, I'm guessing.
Yeah, I read it like 10 times.
Okay.
They're not that bad once you know how to go.
In all honesty, this one is not that bad. Okay. Some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is A equals 10 radical R, where A is the adjusted score and R is the raw score. If the raw scores on one test range from 36 to 90, what is the range of the adjusted scores? So one key thing I see, what did they give me? They gave me a formula. I love when they give me a formula,
Yeah, me too.
because then I don't have to try and figure out a formula. And they also gave me raw scores of 36 and 90. So they're giving me 2 raw scores, 36 and 90. And so they're saying that's the range. The smallest raw score is 36. The largest raw score is 90. They want us to now, in turn, find the range of adjusted scores. So what do I have to do with those that 36 and that 90? Do it twice, yes. These are raw scores. So we're going to put 36 in for R. We're also going to put 90 in for R. So 36 is the low number. I'm going to have a new low number. 90 was the high number. I'm going to have a new high number. So what is the square root of 36? 6. And what's 10 times 6? 60. So now 60 is the lowest score possible. Square root of 90.
9.486832981.
I don't know. I have written down 9.487. It's 9 point something. That's, and on this one, just leaving it 10 square root of 90, that's not really a score. So I would not leave this just 10 square root of 90. If we multiply 10 times this 9.4 number, yeah, 94.87 ... which if we go to a whole number is approximately 95. So we have a new range, and this range is from 60 to 95.
Wow. That makes so much sense. Too.
And the person's lowest score went up so much, but the person with the highest score only went up by 5%. Whoever got like so much of that test wrong, they didn't even get half the credit, but after their curve, they literally got like a D. Luckiest person on the planet.
Okay, guys. You have 12 minutes. Use it. Now, my morning class had a little bit more, but I had people that hadn't started that got done. So, you can get a decent amount done if you get going.
Hold on.